My screen is visible to everybody?
Yes, sir.
Yes, sir.
So, if I talked about you that what is carbon and why we are studying carbon in its compound chapter, why not we study the other elements? So we're going to have the answer for this one. That why we are studying carbon in its compound, why we are not studying aluminum in its compound, why we are not studying sodium in its compound, why we are especially studying the carbon in its compound chapter, why not the other one? This because of the special characteristics of carbon. We're going to discuss this later, that what are the characteristics. Okay, first of all, let me discuss that carbon in atmosphere is present only in 0.03% in the form of carbon dioxide, and in the earth crust it is present in 0.02%, okay, in the form of coal and petroleum. Okay, more than 3 millions of the compound has been discovered, okay, till yet, which are made up of carbon. So carbon is very versatile in nature, and why it is so, we're going to discuss. So please note this question. So many times this 1 marks question comes in your examination, that the percentage of carbon in atmosphere is, that is 0.03% in the form of carbon dioxide. Note it down. Done? Abir, where were you in the previous class? Were you there?
Yes, sir, I was there.
So please note it down. Done? Only you have to write up to this. Okay.
Done, sir.
Done, sir.
Now moving to this one, that why we are just studying carbon in its compound chapter. So as we write the electronic configuration of first 20 elements, okay, like we are having hydrogen, then helium, then lithium, then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine, okay, then sodium, then fluorine, okay. Then we're going to have here, we're going to have sodium, okay. Sorry, we're going to have sodium.
Sir,
here,
neon
here, magnesium here, okay. Then boron is aluminium, then silicon, then nitrogen, okay. Nitrogen, oxygen, fluorine. Here we have phosphorus, sulfur, and chlorine, okay. So if I talked about that one, so you're going to have the electronic configuration. You will find that this is 1 hydrogen is 1. This is 2. This is 2,1, 2,2, 2,3, 2,4, 2,5, 2,6, 2,7.
Sir,
Yes.
argon is there?
Argon comes after the chlorine. Here is argon. Okay. And here is neon. And neon is 2,8, then sodium 281, then 282, 283, then 284, then 285, then 286, okay, 287, and so on. So if I talked about that, these are the first element that are going to have, carbon is the first element that is going to have 4 electrons in their outermost shell. And what is the benefit of this one? The benefit of this one is that carbon can make bond because it is going to have 4 electrons in its outermost shell. So it can make bond with 4 different atoms or similar kinds of atoms. What about nitrogen? Nitrogen can make bond because it is going to have 5 electrons in its outermost shell. So it only requires 3 in order to complete the octet. So it can make bond with three hydrogen atoms, like in NH3. But in carbon can make bond with 4 different hydrogen atoms or 4 carbon atoms, because carbon is tetrahedral. So this tetravalency is very important, but because if I'm talking about the bond formation types of the number of compound that an element can form. So the more the number of arms, more will be the compound, more a compound can make or an element can make bonds with the different atoms or similar kinds of atoms. So if I'm talking about this one, that a carbon is the first element that is going to have 4 electrons in their outermost shell. And this is because of that it is tetravalent. What is this? It is tetravalent. Okay. Noted? Understood?
Yes, sir.
So what is the benefit of tetravalency? So I'm just sure that it can make bond with 4 different and similar kinds of atoms at a single time. Moreover, if I ask you a simple question here, that some of the elements, like talking about this one, this is going to have 2, 4, and talking about silicon is 2, 8, 4. It is also tetravalent. Silicon is also tetravalent. If the question comes that silicon is also tetravalent, then why carbon has 3 million compounds? Why not silicon? Why is the bond formed by silicon atom is not so stable as comparison to the bond formed by carbon atoms? Can anyone answer me this question? Why carbon form more stable bond than this of silicon? Still both has 4 electrons in their outermost shell. Can you answer me this question? Simple reason is carbon is smaller in size than silicon. If I talk about silicon, the atom of silicon have 3 shells, and that is bigger in size. So it is going to have here, and this is the distance between this one and the nucleus of this one is greater. Okay, you understood? So if the bonded pair of electrons are here, okay, you understood? And talking about this one, so who is going to hold the bonded pair of electrons? The nucleus is going to hold the bonded pair of electrons. Nucleus hold the bonded pair of electrons. Okay. So more the bonded pair of electrons closer to the nucleus, more the bonded pair of electrons are closer to the nucleus, the more will be the effective nuclear force, more stable will be the bond, because nucleus is going to hold. If it is far away, here in this case, due to bigger size, the nucleus is far away from the bonded pair of electrons, so the bond is not so stable. Okay. Got it? Understood? That why silicon don't form so many large number of compounds if we start comparing it with the simple reason, the simple answer for this one is that silicon is bigger in size, it has an extra shell. Because of that, the nucleus is far away from the bonded pair of electrons, so the bond is not so stable. I.e., in simple word, we can say in silicon, due to bigger size, the effective nuclear force is less in carbon. Sorry, in silicon as comparison to that in carbon. Okay. Okay. But here a question can comes that if I'm having, let's suppose if I'm having an element, okay, and that is silicon, okay, that is silicon atom, okay, 5, 6, 7, 8, then 1, 2, 3, 4. And I'm just talking about this carbon atom. So if I'm saying the bond is less stable due to the distance between them, but if we compare the positive charge of proton, the proton have 14, if we compare this positive charge of silicon, positive charge of silicon. So what is the positive charge of silicon? How many proton does silicon have? Tell me, how many proton does silicon have? Turn on your camera, everybody.
4 14.
14 protons because it is atomic number is 14. Okay. And how many proton does carbon have?
6.
How many proton does carbon have?
6 proton.
Carbon have 6 proton. So you can say that here the positive charge of nucleus of in proton in silicon is more as comparison to carbon. So the bond here can also be stable. Because it has 14 proton, it is more powerful than this one. The nucleus of silicon is more powerful as comparison to the nucleus of carbon. So what if it is far away? Let it be, but it is powerful, it can attract. So there is a reason why still it is powerful, but it can't hold the electrons. That is the reason. Because let me explain you with the example of a fan blade. If you are having a fan that is going to have only 2 blades and it is revolving, okay, you will be able to see the roof ceiling with this one. Easily the ceiling will be visible to you when the blade moves. Okay. If there is a 4 blade in the fan, then less ceiling will be visible to you. Then if we have 8 blade, then less amount of ceiling will be visible to you. Okay. Okay. So if this fan is having more number of blade, then the ceiling will not be visible in that area with the fan is revolving. Okay. Similar is to this one. If we are having sun and there is a cloudy region, okay, clouds, then still the sun is brightening, or we can say sun is brightening, or it is shining at its full power as it daily. But when it is cloudy region, then you will not be able to see much heat, or you will not be able to feel much heat as you daily. Okay, without. So how it is? What I'm saying here is that when there is 8 electrons in the outermost shell of this this silicon atom, 1, 2, 3, 4, 5, 6, 7, 8. Then when they are revolving around this, they are revolving so fast that they make a shield. They make a shield around the nucleus. So the electrons that are away from in the 4th shell are not able to see the nucleus, are not able to feel the charge of nucleus. It is still powerful, but these electrons, when they are revolving like this, and due to revolution, there is an electron cloud is formed, and this cloud does not, or we can say it shield the electrons. It shields the positive charge of the nucleus, and it will not be able to reach to this one. And this is called shielding effect. This is called shielding effect. Shielding effect. Okay. But if I talked about carbon, in carbon, there is only 2 electrons, and this is the outermost shell. So instead, if it is smaller in size, and moreover, there is no extra shells. Because of that, these 2 electrons are not able to shield so much as comparison to in silicon. So it is able to, means the nucleus or positive charge of nucleus is easily effective, or we can say is effective to the bonded pair of electrons in carbon. Okay. You understood?
Yes, sir.
Understood?
Yes, sir.
Okay.
Sir, could
So,
you repeat the force of the nucleus, the attractive force of the nucleus?
effective nuclear force of nucleus is more in carbon than silicon due to 2 reasons. The first one is the smaller size. Due to smaller size, the bonded pair of electrons are closer. First reason is this one. The second one is poor shielding effect in carbon. Because of poor shielding effect. There is a good shielding effect in silicon. Why? Because it has extra 8 electrons, and they are shielding they are making cloud. When they are revolving, they are making the cloud. Okay. So let me explain you here that whenever we are having, let me explain you, wait a minute. So if I'm saying that if when a carbon is, electrons are revolving, okay, then in that case, the 8 electrons that are revolving, they shield the nucleus, and the nucleus is not visible to the electrons that are present in the outermost shell of silicon because of shielding. The effective nuclear force is not so strong. Still it has 14 electrons. Still it has 14 electrons, but effective nuclear force is not visible. Okay, you understood? Everybody understood? Shweb, Shweta, Shaima?
Yes, sir.
Subhida?
Yes, sir.
Understood? Okay. So let's move further. So please note it down that why is the topic is why carbon is so versatile in nature. Note it out why carbon is so versatile in nature. This is a question also. So first point, note it down. Okay, no need to make this one. Okay, note it down. Tetravalency. It has 4 valence. Tetravalent. The first reason is tetravalent. It has 4 valency, and because of this, it can make bond with 4 similar or different atoms at the same time.
Noted, sir.
Noted. Okay. Now the second reason is because of this. The second reason is small size. So draw to these both silicon and this one, so that you can understand it much better. Yes.
Sir, can you show the previous page?
Yes, why not? Noted. Done?
Yes, sir.
The second is small size. The second reason is small size. Okay. The small size, note it down. Draw this structure, both silicon and of carbon. This is carbon, this is silicon. Draw the structure. And note it down. Short distance from nucleus, large distance from nucleus. Done? Done?
Sir, can you scroll down a little?
Yes, yes. Due to small size of carbon, the effective nuclear force is in carbon to the bonded pair of electron is more. This helps it to make it more stable or stronger bond. And the second reason is because of poor shielding effect of carbon than in silicon. Okay, this is the second reason.
Noted, sir.
Noted, everybody?
No, sir.
Okay, noted. Noted first. Wait a minute. What happened to this? Noted.
Done, sir.
Done. Okay.
Yes, sir.
Next. The third reason is the covalent bond. The third reason is the covalent bond. Okay. Third reason is the covalent bond. Since the carbon is, carbon has 4 electrons in its outermost shell. Okay. So since it has 4 electrons in its outermost shell, it can neither gain 4 electrons nor lose 4 electrons. Why? Because for losing 4 electrons, large amount of energy is being required. Because every time the electron is being loosed by an atom, its size decreases due to same number of proton attracting the lesser number of electrons. There are still 6 proton in the nucleus, but there are 5 proton. So the size of the atom will shrink. And then then these electrons will come closer to the nucleus and more energy will be required to remove the electrons now. Okay. Now if you suppose remove the electron, second electron, then the size of the atoms will again shrink. Okay. So from this, it becomes this. Okay. And then more and more energy will be required to remove this third electron. So it is very, very, very large amount of energy is being required to remove the electrons from the outermost shell of all the 4 electrons in order to get this stable electronic configuration to the helium. Nor it can gain 4 electrons, because if it gain electrons, so only 6 protons are there in the nucleus of this one, and 6 proton cannot hold this 10 electrons. Okay, if it by borrow 4, so for 6 proton it is not possible, because of a small size of carbon. That's because it is the second shell. Okay, so due to second shell and only 6 proton are there, first of all, 6 protons are not capable of holding extra 4 electrons. Because the powerful nucleus is being required. Moreover, due to small size of carbon, okay, there is an electron-electron repulsions take place. Means when you add 1 electron or 2 electrons, so these electrons that are already present in the atom, due to small size, they start rejecting. Okay, they start rejecting due to electronic repulsion. So carbon can neither be lose 4 electrons nor it gain 4 electrons. So what does it do? It shares the electrons. What does it do? It shares. For example, in case of methane or CO2, okay, start sharing with the, like for example, here is methane structure. So start sharing electrons with this hydrogen atoms, and so this duplet will be completed and head the 8 also completed. Okay. Similar for the carbon dioxide. In carbon dioxide, it forms CO2. So this is first shell, then second shell. This is 2 electrons here. This is 2 electrons here. Okay, this is the oxygen atom. That is going to have 2 in the first shell and 1, 2, 3, 4, 5, 6. 6 in the second shell, and here also 1, 2, 3, 4, 5, 6. Okay, so they start sharing. They start sharing here. Okay, you understood? Understood?
Yes, sir.
Yes, sir.
So this is the way that how they are stable. So they can neither carbon can neither gain electron nor it lose electrons, so it form into covalent bonds. Okay, by sharing the electron. The bond formed by sharing electron is called covalent bond, and it is the second strongest bond in the chemistry because it is very much stable and it is not weaker bond. It is the strongest. After the ionic bond, covalent bond is the stronger one. So due to since it form covalent bond. Since the carbon has 4 valencies, so it may bond by sharing 4 electrons to complete its octet. Such bond is called covalent bond. And covalent bond is stable bond in the second stronger bond. Not this, we can say second strongest bond after the ionic bond. Okay. That's why the compound is stable. So note it down.
Noted, sir.
Other students?
Sir.
One, sir.
Done? Done?
Yes, sir. Done.
Okay, should I move forward? Okay. So why not everybody is answering? Shoaib, are you there? Shweta, Abir, Jobita,
Yes, sir.
Yes,
and
sir.
Saima? Done? Okay. So let's move to the next property. The next is catenation property. What is catenation? Catenation is self-linking property of an element. Catenation is self-linking property of an element. What does it mean? Self-linking property of an element. Self-linking means that an element can bond with itself. Okay. Self-linking means, for example, chlorine make bond Cl2. This is a self-linking property. OO make bond with it, which make O2. It is a self-linking property. Sulfur make acid molecule by making 8 sulfur atom bonded together. It is a self-linking property. So self-linking property of an element, we call it catenation. What is catenation? Catenation is a self-linking property of an element. And due to the above 3 reasons, one is the small size, tetravalency, and covalent bond. Due to the above 3 reasons, carbon show catenation property to the maximum extent. Here, sulfur can make up to 8. S9 is not possible because this is not a stable molecule. Oxygen can show maximum up to 3. Ozone. Okay, C fluorine can show up to 2 atoms, fluorine atom bonded together. Sulfur can show up to 8. Phosphorus P4 or P5. Okay, so we can have some elements that can bond together, but carbon, there is If I talk about carbon, in carbon, hundreds of thousands of carbon atoms can bond it together in a straight chain. In a straight chain, okay, they can bound together in branch like this. In branch, okay, they can bound together in rings like this. So they can bound together in rings, in branch, okay, due to catenation property. Catenation is a self-linking property which carbon shows to the maximum extent. Okay, due to the above three reasons: small size, tetravalency, and covalent bond. Okay, you understood?
Yes, sir.
So, what is catenation? Catenation is a self-linking property of an element. Note it down here. That catenation is a self-linking property of an element by which an element can make bond with its own kind or similar atoms. Done. But in
Done,
case
sir.
of carbon, due to small size, covalent bond, and tetravalency, carbon show catenation property to the maximum extent. As a result, it can make bond in branches, straight chain, and rings. Note it down. So many times this question is being asked, what is catenation? So don't think that carbon is showing this catenation property, other element don't show. Catenation is a self-linking property. Okay.
Done, sir.
Done, everyone?
Yes, sir. Done.
Okay. So is there anyone who's still writing? So here a question comes in examination. Both silicon and carbon are tetravalent, but silicon can make chain up to 7 to 8 silicon atom bonded together, while carbon can make chain up to 100 of thousand of carbon atom bonded together. Means silicon can make chain up to 7 to 8. Okay, while carbon can make chain or branch up to thousands of carbon atoms bonded together. What is that? What is the reason? So note it down. Because of, this is the same question that we have discussed. Because of small size of silicon, sorry, of carbon. So because of small size of carbon, note it down. This you have to write here. Carbon has 2 shells and silicon has 3 shells. The bonded pair of electrons has more effective nuclear force than the bonded pair of electrons In silicon, as a result, the bond is more stable in carbon than silicon.
Sir, we have to copy the question also.
Yes, copy the questions because this is an important question. This is a question so many times. It is an NCERT question. Okay.
Yes, sir.
Second, in carbon, the shielding effect is less. Or you can write poor. Is poorer than silicon. So the effective nuclear force is called Z effect. Z effect. Okay. In carbon is more than silicon to the bounded pair of electrons. This is an NCERT question. Done?
Sir.
Noted everyone?
Yes, sir.
Okay.
Sir, can you show me the slide?
You're still writing?
Yes, sir.
Noted.
Done, sir.
Done?
Yes, sir.
Okay.
Yes, sir, done.
Sir,
Yes.
sir, can you please show the page again?
Okay. Done, Jobita?
Yes, sir.
Okay. So let's move to the next part here. Here a question comes that you have to write the question in your, this was a board exam questions. Okay, that why carbon cannot make C4 positive ion or C4 negative ion. It means it is losing completely 4 and it is completely gaining 4. So I have explained you this one. As this is a carbon atom and it loses 1 electron, then its size will continuously keep on decreasing. And since why? Because 6 protons are here 6 electrons. But here in this case, when it loses 1 electron, it is 6 proton and 5 electrons. Then when it loses, then 6 protons and 4 electrons. So since as we remove 1 electron, then the greater number of protons are attracting the lesser number of electrons. Greater proton and less electrons. Because of that, the size of the atom gets shrink because this will be attracting the, and as a result, large amount of energy will be required to lose the electrons. Okay. So please take the screenshot of this one. I will give you the homework for this question. So take the screenshot. I'm just written here. So why carbon cannot lose 4 electrons and form ionic bond? So the answer is, as the atom starts losing its electron, the size of an atom decreases because greater number of protons are attracting the lesser number of electrons. So the atom decreases. So the size of the atom decreases, which make it harder to lose 4 electrons. Okay. So it is very, very hard to lose 4 electrons for a carbon atom. Okay. Understood?
Yes, sir.
Have you taken the screenshot of this one?
Yes, sir.
Yes, sir.
Okay. This I'm writing because this question has been asked previously in the previous exam. Why is carbon can't get 4 electrons and 4 C4 minus ion? The simple answer, because a powerful nucleus is being required to hold extra 4 electron, which carbon atom can't just. Okay. So in the conclusion is carbon make covalent bond. Okay. Got it?
Yes, sir.
Now, covalent bond is the bond that is formed by sharing of electrons. Sometimes the structures of different elements may be asked. Example for to draw the Lewis dot structure of for example, N2 molecule, O2 molecule, Cn2 molecule, CO2, NH3, okay, SCl. So these are the molecule, okay, CH4. So these are the molecules that are going to form covalent bond. Okay, when 2 atoms are combined together, they are also combined by covalent bond. Okay. So if I'm talking about that N2 molecule, the structure of N2 molecule may be asked in the examination. So you have 2 nitrogen atoms. Only the electrons that are present in the outermost shell of an atom you have to draw. And you know very well that nitrogen have 2,5 electronic configuration, so it will share 3 electrons in order to complete its octet. So the number of electrons that it need to be shared, put it here, draw it here, either in the form of cross or dot. It's your choice. Okay. Now the three electrons are shared to make the circle with all the electrons here and make this. This is N3 molecule. Sorry, N2 molecule. Got it? Got it?
Yes, sir.
Three electrons will be shared. If we are having oxygens, oxygen is going to have 2,6. Then how many electrons will be shared in the oxygen?
2.
2, because it required 2. So the number of electrons that need to draw it here. And then remaining 6. The remaining 4 you can draw like this. This is the 6. This is the 6. Then you have to take the electrons. Okay. And count it that one circle should have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the O2 molecule. Okay. Got it?
Yes, sir.
So if it is being asked to draw the structure of CO2, how will you draw the structure of CO2?
Two oxygen sharing with 1 carbon.
Yes. 2 oxygen atoms. Okay, because carbon need 4 electrons. Okay, 4 electrons to complete its octet. And oxygen can share, one oxygen can share 2. So here 2 for this oxygen and 2 for this oxygen. Carbon is going to share. This circle is going to have 8. This circle is going to have 8, and this circle is going to have 8. Draw this CO2. Only the electrons that are present in the outermost shell of an atom is going to draw. Okay, don't draw whole 6 electron of carbon. Carbon has 2, 4 electronic configuration. Draw only outermost shell. Done.
Done, sir.
Okay. Now, if we have NH3, ammonia molecule, how will you form? N. How many electrons are there in the outermost shell of nitrogen? Outermost shell of nitrogen.
5.
5. And these are 3 hydrogen. Nitrogen need to share 3 to complete its octet to make the shared electron 3 like this. And remaining 2 here. The 5 and hydrogen. It's not necessary that you need to, it's your choice. You can draw it like this way. It's your choice. You can make it like this, 1, 2, and 3 here. Okay, like this. You can make 2 here, 1 here, 1 here, 1 here. It's your choice, because in 10th standard we don't study the shape of the molecule. We study this one in the 11th standard. So you can draw like this. Hydrogen need to complete duplet, so it will be completing its duplet. And this nitrogen is going to complete its octet. Okay. Got it? Got it?
Yes.
This is the molecule NH3. 8 has been completed. 1, 2, 3, 4, 5, 6, 7, 8. Now the last one is draw the structure of, so many times, draw the structure of S8 molecule. So sulfur is going to have 8. So how will you make this one? Keep the sulfur, draw like this. 1, 2, 3, 4. At this position, 4 has been done. Okay. And then you can first draw either in the octahedral shape. And to draw the octahedral shape, you have to put 2 here and put 2 here. Means first you have to draw the rectangle 1, 2, 3, 4, and then a little bit closer to this one and then above this one. Little bit closer to this one and okay, this is an octahedral shape. So put the sulfur like this: 1, 2, 3, 4, and then 5, and then 6, and then 7, and then 8. Okay.
Yes, sir.
And only one electron is being shared here, because sulfur has 2, 6 electronic, 286 electronic configuration. So it requires only 2. So one sulfur when bonded with this sulfur and with this sulfur, so single bond will be formed here, single bond will be formed here. Okay. So one sulfur, so you can draw it like this. The 2 bond, 1 electron for this one, 1 electron for this one. 1 electron for this one, 1 electron for this one. Done? Now you have shared, you have drawn the 2 electron of each. 1 and 2 for this one, 1 and 2 for this one. So 2 electrons you have drawn of each, but remaining 4 is left. So draw 4, 4 here. 1, 2, 3, 4 like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now you have to make this a circle that is having the 8 electrons. So 4 here, 4 for this one, 2 for this one, and 2 for this one. So bring this one, a circle with this one, 8. Okay, like this. And then again, like this. 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 Again. This is how a sulfur acid molecule looks like. Okay.
Yes, sir.
Draw it.
So it should be 2, 8, 6, right? Since sulfur is 16.
Yes, 2 comma. Yeah, I have just written here 286. I have just crossed it. 286. Yeah, noted.
Noted, sir.
Done, sir.
Is there anyone who's writing? Okay, so that's all for today. We'll discuss in the next class. Okay. So those students who are for the next batch, Shoaib, sorry, Adil, and Karishma. Who is Karishma?
Good evening, sir.
Good evening. And who is Karishma? Karishma Chaudhary.
Yes, sir.
You are the new student.